In this section, I'm going to talk about how to version your HTTP and REST APIs. As you think about versioning your service over time, the most important thing to consider is the overall customer experience. You have to empathize with your customers and get a sense for what kind of pain you might be putting them through as your service versions. What I put on this slide are actual customer quotes. And as you read some of them, you'll see some of the pain and distress that's been in the customer's minds. In Azure, we have two requirements to really improve the customer experience. The first requirement is that customer workloads must never break due to a service change. This is actually a policy that's been in place for many years now. But a newer policy is one where we want customers to be able to adopt a new version of a service without requiring any code changes at all. That is, the customer should be able to adopt the new version of the service, but they should also be able to adopt a new version of a client library that wraps the service and not have to make any source code changes unless the customer wants to leverage some of the new features that are available in the new version of the service and its corresponding client library. Let's talk a little bit more about the Azure SDKs and client libraries. First, some terminology. Microsoft has one Azure SDK per language. So there's just regular REST, which customers can always just use any programming language in order to make REST APIs. For that, we don't have an SDK or client library. But then we do have Azure SDKs for C, C++, Go, C# or .NET, Java, JavaScript, and others. And we may add other languages over time, and some of these may go away over time, depending on what the community at large requires from us. Each SDK has one client library per service. So there would be a client library for storage, and a client library for Key Vault, and a client library for speech recognition, and so on. Right, those are our terms that we use. There's one SDK per language, and each SDK has multiple client libraries, one per service. The client libraries provide a bunch of nice functionality over just making regular or standard REST API calls. The client libraries, they provide a service object model. So it's not just a bunch of flat APIs that are all post, put, delete, get, patch, right? They have good method names associated with them, and there's an object hierarchy. Like for storage, you have an account, and from an account you create a container, and from a container you can create a blob, and then there's 3 different kinds of blobs, and so on. Client libraries also give you code completion in your programmer editor of choice. So when you type in like blob client dot, it'll show you all the method names that are available for you to manipulate a blob. Of course, one of the great features of client libraries is that you get type safety in type-safe programming languages, so that if a method requires an integer and you pass it a string, that code won't compile. So the code you end up writing as a customer ends up being more guaranteed to be correct, and you'll find out more bugs at compile time as opposed to runtime. The client library also has support for simple patterns in it, like paging over collections, or doing long-running operations where you have to poll an operation multiple times on the service in order to find out if the operation succeeded or failed. The client libraries have support for various credential types, so that when you authenticate with the service. The client libraries have built-in retry mechanisms. As I've been talking about idempotency a lot in this course, the client libraries will automatically, if there's a failure or a throttling, they will retry the operation if there's a chance that it will succeed in the future. So that you, the customer, you basically get retries for free and exponential backoff and so on. The client libraries do client-side logging, where a customer can look at every HTTP request that's outgoing and what the response was that came in. The client libraries have telemetry support for setting up the user agent headers to send that information to the server, so the service can track what kind of client libraries, what language, what version, what operating system is being used to make calls into the service. The client libraries have support for distributed tracing, they have support for cancellation of I/O requests, and much more functionality. So they really provide a lot of features over just making raw HTTP requests from a client application. When a service changes its APIs or its parameters or its payloads, well, that of course changes the API contract of the service. And then it affects all these client libraries that have encapsulated that contract as part of the API surface area. And then if that changes, that affects all the customers that are using these client libraries. So due to our rules of breaking changes where we don't want any, well, if you make a breaking change, that has this enormous impact and an enormous rippling effect that scales out and really can adversely affect the customer's experience of using your service. It can also impact the CLI and the portal and bicep tools and, of course, all the customers. A new client library must not require any customer code changes in order for the customer to have a good experience. And it's having these client libraries, it further constrains the kind of changes that a service can make. I talked about enums earlier in the course, for example. And a service might use enums in its open API specification, but because of the way client libraries in various languages handles enums, there's a lot of potential problems with using enums. Now, there's more reasons why breaking changes are forbidden. It's not just that the customer might have to modify their code, but we want a thriving ecosystem around our services. So we hope that some companies will build third-party libraries on top of our client libraries. And if you have a breaking change, it can actually make it so that the whole application that the customer wants to build is not buildable or not runnable at all. So let me explain how this can happen. Many languages can't load a version 1 and a version 2 of a library at the same time into a single process. And if an application has a link to version 1 and version 2 and needs them both, because that language can't load them both, the application simply can't run at all. Now, for languages that can do this, and there are some that can, there are still some significant problems with it, such as size. Especially for things like JavaScript, it can load different versions at the same time, but it has to download those and load them in the same process, so the size is much bigger. And also, if there's any singletons in these libraries, well, you now have a version 1 singleton and a version 2 singleton, so they're not unified anymore, and maybe they're doing some client-side caching of resources. Now you have two separate caches instead of a single unified cache. So while in some languages it may be possible, there are still reasons why this is not ideal related to size and multiple singletons. Also, when you make a breaking change to the service or to a client library, that affects or invalidates the entire ecosystem. There may be third-party libraries out there that are using a library. There may be documentation written for your libraries, and there probably is documentation. There are samples out there, there are blog posts, there are videos. So when customers are trying to learn how to use a service, they might look up online how to call a method. Well, if you've changed the parameters to that method, the order, the names, the data types, then the customer might find a blog post or video online that explains how to do something, but because you've now changed it in your service, that information is no longer valid. And now the customer can't trust these things anymore to know if they're applicable to the version of the library, the latest version of the library that they are now working with. So let me explain a little bit more about this. The first bullet here, where many languages can't load two different versions of a library at the same time. Let's say that we have a client that's building their application, and the customer's application takes a dependency on some client library, version 1.3. And the application also takes a dependency on a third-party client library, we'll call it library A, and that library takes a dependency on the same client library, but version 1.0. And the application also wants to take a dependency on another third-party client library, we'll call it library B, but this one has taken dependency on the latest version of the same client library, version 2. Now, we can assume that version 1.3 is a backward compatible, just a later version of client library 1.0. But we could assume that client library 2.0 is not backward compatible with version 1.0 because maybe it had some breaking changes in it. Well, this is all fine and this may build perfectly fine, but at runtime, we're going to try to load into a process the app, the library A, And then the app needs client library 1.3 and library A needs client library 1.0. Well, only one of those will be loaded at runtime, and it will be the latest version typically. So that will be client library 1.3. So now the app and library A will both be using client library 1.3, and hopefully that's backward compatible with 1.0, so everything should work fine. But now when the process tries to load library B, it requires client library 2.0. But as I said before, a lot of programming languages can't load both of these, version 1 and version 2 at the same time into the process. And so the language can't load library 2, the whole process can't run now, and the app is completely unusable at this point. And this happened because we introduced a breaking change somewhere, some other thing took a dependency on it, and now we need to load two different versions at the same time, but the process can't do it, or the language can't do it. And so now the application is completely unrunnable, and we've put the customer who's building this application, or really all customers of the third-party library B2 potentially, into a very bad state where they can't go and talk to our service anymore. We have a versioning strategy. Whenever we make a request to an operation in an Azure service, we always specify an API version query parameter, and we use this in order to signal new features. For example, let's say we're talking to the API contoso.com endpoint, and in the users collection, there's a resource in there called Jeffrey, and we wish to manipulate it in some way. So whether there's a get or put, it doesn't matter. We always put a query parameter at the end of API version equals some value, and that value is always a date-based value like this 2021-0727 number. When you are introducing or testing out some new features that you're adding to a service, then we recommend that your API version include a suffix of -preview at the end of that. If it's in general availability and it's not in preview anymore, then you would strip the -preview suffix away from the API version parameter. Do not put the version in the path. Some services do this and we can't break them now, but they've done it in the past. This is not ideal because the path's purpose is to identify a resource in the service regardless of version. It's not like you have version 1 of a resource, version 2 of a resource. You have a resource and you can access it using version 1 behavior, or you can access it using version 2 behavior. That's the way to think about this. So now customers can opt into these new behavioral features if and when they desire, because the client has to go and make the request with this API version value. Happy customers may never opt into any new features that you add in a new API version. If the customer does opt in, then our rule is that they should only have to change existing code in order to leverage new features. In other words, the customer should be able to just accept the new version of the service and accept the new version of a client library that talks to that new version of the service. And we don't want to force any customer source code changes in order to adopt that. Now, if the customer wants to leverage some of the new features in the new version of the service, then of course it's okay for them to modify their code in order to leverage those new features. So what this really means is that the concept of versioning a service of an API is really a misnomer. In reality, you're just adding new APIs and you're just stating that the newer version is preferred over the previous, but it's not mandatory. Customers do not have to upgrade. They can stay with whatever version that their code has been tested on and working on for years. They should be able to stay that way for as long as they want. New versions of the API run alongside the previous versions of the API. Note, too, it's very important that resource state must be backward and forward compatible because the resource state actually spans all versions of the API, right? I can go and put a resource there using a version 1 client. I can then go and get the resource out using a version 7 client and vice versa, right? That all should continue to work just fine. So what this really means is that changes to the underlying resource structure, be aware that they span all versions of the API, so the kind of changes that you make there, you have to be very thoughtful about. For example, one example of a change that would be a very bad thing to do would be to change the maximum length of some string in the resource. The reason why that is a problem is because a newer client that talks to a newer version of the API, it might be passing in that string value that's, let's say, 100 characters long. And let's just say the old length was 20 characters. So now a version 1 client tries to do a get operation to get that string value, but it may allocate a buffer that's only 20 characters big. It can't put the whole 100 characters into it. And even if it could put the whole 100 characters in on the get, if that v1 client then tries to write it back to the service, that version 1 of the API should be checking to make sure that the string wasn't more than 20 characters, but now it would be 100 characters, and so now it would be failing and not accepting the new value. So again, you must be super, super careful when you're changing a schema, how this would affect old clients as well as new clients. Let's talk about service versions and client libraries now. Well, different clouds can support different versions of a service. In Azure, we have public clouds, and then we also have Azure Stack Hub. And it could be that we have a service running in the public cloud, and maybe it supports 3 different API versions. But maybe in Azure Stack Hub, we have the same service running there, but it may only support one of those versions. And because it's customers who control when to upgrade Azure Stack Hub, whereas Microsoft controls how to update their public cloud data centers. So a customer who wants to leverage this service can go and grab a client library in the language of their choice, that means the SDK of their choice, that they wish to use to go and talk to the service. Now, if the customer knows they're talking about against Azure Stack, then they have to get a version of the client library that supports the 2019 version. If the customer knows they're talking to a public data center, then they could get a version of the client library that talks to 2019, 2020, or the 2021 version. Right? But the customer has to know what cloud they're talking to and what version of the service is there. And then the customers have to be able to look in documentation for the client library to indicate what version of the service a client library supports. Now, to reduce customer pain, Microsoft's client libraries try to be backward compatible. That is, the API version can be a parameter that's passed in when the customer is creating a client in their source code. And then when they make requests to the service, that API version is the one that will be passed from the client to the server. Now, this assumes that later versions are backward compatible with newer versions, of course. And if that's not the case, then this is not guaranteed to work. So we're trying to simplify for customers that there's not this version of the client library for this version of the service, this version of the client library for this version of the service. What we're trying to say is this client library supports these versions of the service. And then the customer can grab any client library that supports the version they want to talk to, and newer ones should support later ones of the service. Newer client libraries support later versions of the service. And then the customer can grab the latest one, and then it can work backwards in time with API versions. And this makes it much simpler for customers to rationalize about this, understand what's going on, but it really only works if the services maintain backward compatibility between the different API versions. As I've mentioned many times, a services API is a contract with the customers. So any contract change, that is any change to the API, it really requires a new API version. Even additive changes require this, or ambiguities will arise. So let's say, for example, that in some cloud, there's a 2019 version of a service. And then that service team decides to go and add some new optional property to a response or to a request, or add some new API that's supported, but they don't change the version of the service. So it's still 2019-01-24. Well, this failure to change the API version can cause confusion. So let's go through a couple of examples. The first is, when looking at the documentation for this API version, does that documentation include the new feature or not? Let's say it does include the new feature because you've updated the documentation. Great. But on some cloud, that cloud may not have the latest version of this version of the API. And so when the customer's code tries to use this new feature, but to the same API version, but that version on some cloud doesn't support it, the call fails. And the customer won't understand why. Because they'll say, the service will say, this is an unknown operation. And the customer will say, well, the documentation says it's there. It's the same API version that I'm using. So what do you mean unknown operation? And now the customer has no idea what to do. This usually will end up meaning a call to customer support to try to figure this out. And the customer support people also can't figure it out for the same reason. And so it's a problem the customer has that's very hard to diagnose and fix. Also, does a client library for an API version include the new feature or not? So if you add some new API in a same version of a service, and then we create a client library, we document that this client library is for this API version of the service, but was it version 1 of that API version that didn't have the feature, or is it version 2 of that API version that does have the feature, right? It's very confusing, and so don't do this. When you change the contract at all for your service, change the API version so that it all makes rational sense. On this slide, I talk about Azure's breaking change policy. If you're a Microsoft employee, we have Azure's breaking change policy written up in a formal document that non-employees wouldn't have access to. I put the URL on the slide here of where you could go in order to read all the details about that policy. But I'll summarize that policy for you now. Azure's policy is that any service or SDK change forcing a customer to change their code is considered a breaking change. And we really, really, really want to avoid doing this because it upsets customers. They have to modify their code. They have to redeploy their code. They have to retest their code, causes a lot of customer pain. So we really, really, really want to avoid it. But there are some times when a change is necessary. Sometimes it's for security reasons or compliance reasons. Sometimes it's to fix a very heinous bug that a lot of customers are getting, are experiencing and getting beat up on. So if it is unavoidable if it's impossible to avoid the breaking change, then Azure's policy is that we notify all customers that the breaking change is going to happen, and then we give customers 3 years to modify their code. The breaking change cannot be put in immediately, and then you just break all the currently running customer workloads. That would be very bad and really hurts and damages our reputation with the customers. So we notify customers, and then we give them 3 years to modify their code. If it's a security or compliance issue, then we can limit it to 1 year instead of 3 years because we don't want security holes to last for a very long time. The table below kind of walks through a timeline and what the service team actions would be. So let's say that on 2021, January 1st, the service team ships version 1 of some service, and the customers are already using it. Then a couple months later, in June of 2021, the service team decides that they want to break some customers. Let's say they want to have a field and they really want to remove the field from the schema. So now the service team would craft a customer notification that would be sent out to customers, usually by way of the Azure blog, or all Azure subscribers could receive an email with this information in it. And this will announce the pending break or breaks to all the customers. Now, at this point, the customers can't do anything about it yet. We've just alerted to them that a breaking change is going to happen. And so they can start thinking about it and how that's going to impact them. Then the service team, in my example, 2 months later, on August of 2021, the service team goes and ships version 2, which has the breaking changes in it. In this case, let's say they have removed the field. So the field is no longer supported by this version 2 of the service. So at this point, version 1 is still in production and customers can continue to call it. Version 2 with the breaking change is now also in production and customers can choose to call this. But in order to call version 2, they have to remove all references to that removed field from their source code. So customers now have a 3-year period to go and modify their code And ultimately, they have to abandon the service version 1 and have their code talking to version 2 of the service. The whole goal here is we're trying to avoid forcing customers on our timeline to go and modify things. We're giving them this 3-year period, or 1 year in the case of security or compliance. Also, another thing to note is that we want to avoid forcing customers to move resources from Service v1 to Service v2. That's just an awful customer experience. In other words, it's nice, very nice, if the Service v2 is capable of still using the v1 resources. Maybe just now it ignores that field that was in there. And the v2 doesn't allow the field to come in or be passed in from a client anymore. Right? In that case, we don't have to do anything to the resources, and the existing customer resources remain good. But if the service really needs to for some reason, it could even say to the customer, your v1 resources, we can't use them anymore. So when we bring that version 1 of the service down, we will destroy all those resources. You, the customer, have to migrate them from version 1 to version 2 with whatever modifications are necessary in order for your resources to continue to live up in our service. So as a service team is considering breaking changes, really think about this hard and really try to avoid forcing customers to migrate the resources from one version to another. Once the Service v2 has shipped, and here I'm showing that it shipped in August, which was 2 months after the initial announcement. That's not necessary. You could make the announcement and put v2 available to customers immediately if you want to. And v2 could have been in preview for a while too. That way you already had customers using it and experimenting with it and playing with it, and you're getting feedback on it. All that stuff is good, okay? Once the Service v2 is in production, then the Service v1 is basically supposed to sit there for 3 years. You could add features to the Service v1 if you really want to, but it's kind of awkward to do that now because usually a new version of the service has a new date. And so your v1 service would now have a later date than your v2, your modified v1 service would have a newer date than your current v2 version of the service. And so customers who are looking at the latest API version in documentation, they would now be very confusing to them. Are they using a modified v1 or is it really supposed to be on v2? So it's possible that you can add features to the Service v1, but when you ship that, you're going to have to use an old API version date, something that, that's like before when your Service v2 actually shipped, so that customers can rationalize about these kind of split path that you have now between these different versions. And then once your Service v2 is up and running and your customers have had the 3 years of notification, then here I show on the slide that in the year 2024 of August, that's when the service team can stop supporting Service v1 and just bring that down. And now any customer or client code that's trying to talk to Service v1 will fail at this point, but you have given those customers 3 years notice and the opportunity to migrate their code to the new version. And so it's on them at this point. And now I'd like to talk about the service versioning workflow. So let's say that you have a service and it's currently in GA, general availability, and the API version of that service is 2019-12.01. Now you're working on a new version of that service, and you want to put that into preview. I'm not talking about breaking changes now. I'm just talking about you're just enhancing the existing service that you have. So you want to create a new version of the service, and you want to put it in maybe private preview or public preview. It doesn't matter. We handle them the same way. So we would give this new preview version of the service a new date like 2020-01-01, and because it's in preview, we would use -preview suffix on the API version. So if it's a private preview, now you can just tell your private preview customers, this is the API version to use, here's some documentation, and use it. And when you decide to make it public, you just make that documentation public. The service itself doesn't change at all. Okay. Now, once you've put this in and you start working with it, it could be that you're getting feedback from a customer during the preview cycle, and you might want to have a preview 2 or a preview 3 over time. So our rules are that any breaks to a preview require a new version of the preview. But you are allowed to break APIs during the preview cycle between previews. A preview is not allowed to break what the last GA was, but between previews, you can break things. This is, of course, the main reason why we even have previews, is so that you can get feedback from customers, and then you can respond to that feedback and improve the service. So if you're introducing a new preview, and it is not backward compatible with the previous preview that you shipped, then this new preview must have a later date, so a later year, month, and day on it. And the old preview must continue running in the service. This avoids breaking your customers who are using the old preview. However, when this new preview releases, you will notify customers that the new preview is available and that the previous preview will retire in just 90 days. So we talked earlier in the deck about how when you're going to make a breaking change, it's a 3-year notice. For previews, it's only a 90-day notice. And your customers know they're using a preview, so they're anticipating this, and they have to be along with you on that ride as you're trying to improve the service and they're giving you feedback. So we think this policy actually works quite well. So you'll notify customers that the old preview will expire in 90 days, and then the customers have to migrate their client code in order to use the new preview version of the service. Also, in Azure, we have a rule that a preview period must not last more than a year. Customers are very frustrated then when we have services that are in like perpetual preview or previews that last incredibly long time. So if your service needs to be in preview for over a year, then you need to talk to some people and you have to get an exception to the rule. So it's possible, but it requires some exceptions. Finally, when you're ready to take your service out of preview and make it become the new version or GA version of your service, then you go to the API version and you can either update the year, month, and day, or you can keep the last preview year, month, and day, but you remove the -preview suffix, of course, because this is no longer in preview. It's now the latest GA version of your service. So as I mentioned here in the red box in the bottom left, the year, month, and day can match the last preview, or it can be later. That's up to you to decide. When the GA releases, again, you notify customers that the last preview will retire in 90 days. So your preview customers still get to use it, even though you went to GA, but only for 90 more days, and then they have to migrate to the GA version of the service. Any changes to the GA version requires repeating this whole cycle again, and you start a new public and private preview, and everything in the blue box restarts. As I've been saying all along, the new GAA must be backward compatible with the previous GA, or you have to adhere to our breaking change rules where notify customers in 3 years and so on. If that's impossible, then you notify the customers, and then you can retire the previous GA in 3 years.